video, we are going to discuss about alpha beta pruning. So we start from the first point that we also call alpha beta pruning method, advanced version of minimax algorithm. I mean to say that the time complexity and performance minimax algorithm, we calculate it in b to the power d. If we have game tree and in that game tree branching factor is b, means every node has b number of child. um every node has number of child, the branch factor b, and the depth of the game tree is d. So the time complexity we get of minimax order to b to the power d. And it is like this because we explore all the nodes and what is our main aim, that we have to find the best path for the max player. So max player that we consider at root level. So we have to explore all the nodes to find best path for him and time complexity. We get this order of b to the power d, and in alpha beta pruning what we actually do in this is that we have to cut off his this exploring, and I have written this as important point here, that cut off search by exploring less number of nodes means when we will explore less number of nodes, then obviously our performance will increase and it will take lesser time in alpha beta pruning. And how we actually do it, if we have already founded a path, if we have already founded the best path, then we will pruning all the remaining paths. Spooning means to cut off uh, to cut off particular things. That means we'll not explore them because they are not creating any problem in our final decision. If we already a path founded them, so we will not explore the remaining path. So we'll pruning them, and we call this method as alpha beta pruning. And what are alpha beta actually? Alpha and beta are two values we are generally consider alpha for the max node and generally we consider beta for the min nodes. But how do we find out the values of this alpha beta and how we prune the values means how we prune the path or nodes the nodes, and how do we explore less number of nodes rather than minimax, we'll see those points from this particular game tree. So I have already taken the example game tree bigger, so what I can explain all the cases in this only, so you understand that how alpha beta pruning works. So in game tree, see, when so in game tree on root node we have max, on next we have min, and then leaf nodes also. So what we generally consider is that I am a max player and max player has took his turn. He chooses a path for him. Then mean will choose. Then mean will choose the main. Then mean will choose. Sorry, and the max will choose. Then again mean will choose. And we already have utility at the terminals, we already have the values. So we will see how to find out the values of alpha and beta with help of these given values, and how we don't have to explore nodes, which nodes we have to explore, and which we don't have to explore, even though we get the best part of this is this alpha beta pruning. So let's start first of all. You know that we move according to their first search. So according to their first search, will search to this node, and we have uh, value of uh, we have a value of 3. We'll fix beta value of 3. If we move for DF, according to DF, so we'll get the value, max value, mean value of 3 and max value of 4. So that means beta will show that value of 3 and alpha. If max player or alpha choose that particular path, so that is the value equals to or greater than equals to 3. So, uh, so we have a value of 3. We'll fix beta value of 3, but mean value of this node we don't know that, but uh, but uh, but but by this we got an idea that if this node's beta value is 3, so mean value will be equal or less than 3. Obviously, if we get 3 values of this beta, then mean value of this node either will be 3 or greater than 3. So we have a value of 3 already, or will be less than 3, or we can say that if we move to this node, as we move to this node, it is a value of 4. Okay, if we choose that particular node, then we'll get a value of 4. Uh, okay. Obviously, it is a mean node, then beta value will remain in 3 because this value is larger. Now we know that this node mean value is 3. It is confirmed now. This node have value 3. So how did we consider it? We saw this value. Fi 3 is fixed value of beta, so that can either be 3 or less than 3, because if it 2 here instead of 4, then obviously its mean value will be 2, and beta will also be a 2, because we consider beta in decreasing generally. We take upper bound in beta means plus infinity, and then we decrease its value. So we'll choose minimum and we take alpha values in an increasing way. But you don't have to take minus infinity or plus infinity. You can directly do 8. And I'm explaining it to you in a simple way. Now we have fixed value of this node is 3. Now here we have max. When one node value is fixed, neither mean or max value gets fixed. So we take it above here. Max value is alpha's value will be 3. Okay, uh, will be 3, and max value of this node we don't know about that, but we know that max value of this node will be either 3 or greater than 3. Mean to say equal to either 3 or greater than equals to 3. So we can say that obviously 3 is its value, but we have to move towards max. Then max means minimum it will be 3, maybe is greater than 3 if we consider this node. But we have a guess now that its max value will be greater than or equals to 3. So we know this form it now we go towards this and then towards 2, because in this graph we can see that the starting nodes is A. After A we will get B and C path, and B path will show the two nodes respectively D and E, for and D will get H and I, and E will get J and K. If we choose the D to H path, then the value of beta is 3, our maximum value is 4. So it is searching by deepest DFS method. So it is go to the deep first. Then if it will get the ghosted, then okay. If not, then it's back to the right hand side. Okay, because we are taking here about mean. So the mean value of this node is 2. The mean value of this node is 2. Mean value of this node is so if we are taking here about mean, so mean value of this node is will either be 2 or less than 2. Either it will be 2 or it can be less than 2. But as we see here, alpha value here is 3 max already decided here. So the maximum value here is decided is 3 already. So the max value is already fixed here as 3. So here, if we choose that particular part, we will get the maximum value of 2. So do you think that alpha can change its value 3 to 2? It is possible. It is not possible because the value is already. So we'll see that uh, if we got part that I can take you alpha for 3 or greater than 3, minimum will be 3, saying it will take a minimum value of 2 if I choose the I path. Okay, if I choose the H path, it is my minimum value of 3. Then obviously we will not consider this one, means there is no use of exploring this node. Will Purne it means will Pune, it means will not even search it. Then here we have a fixed value of alpha that is maximum of 3. If it will take me to this path, then I will get the utility of 3 for sure. Now we take this value, above we have the value of beta here, which is 3. But mean value of this node, either it will be 3 or less than 3. You just simplify have to mean value will either be equal to 3 or less than 3 when we will explore this. Maybe we find lesser than this, but minimum at will be 3. As we go down there, we have the value oh 7. We fix the beta value as 7. As we fix beta value 7, mean value for this node. If we talk about a minimum at minimum level value will neither be 7 or less than 7, obviously, for this node. So this value will either be 7 or less than 7. But as we explore 8 now 8 8. So now that keep beta value as 7 only, mean value of this node is 7, also 7. Now we already have fixed our value. We take this value above, now we fix the alpha value as 7, but this node max value will be, we're taking about the max node here, it can be either be 7 or greater than 7. So also it can also be greater than 7. We don't know till now, but minimum will be 7 for sure. But as we saw, the upper level, this level is saying that I will take beta value 3, means beta value is 3. So this node mean value will be either it will be 3 or less than 3, but this path, uh, but this path, that means J path or K path, suppose both have the greater value than the H path. But we are setting that particular value here, alpha equals to 3. So alpha so already this path is saying that the uh, value is 7. So obviously it will not be any benefit on going on this path. If we go on this path, even we get alpha value here 1000, but it will not select it only. It has got it minimum beta value as 3. Either it will be search for 3 or less than 3 because beta already decided here. So this path is spooning only or cutoff. Okay. So uh, obviously it will not be any benefit on going on this path. If we go on this path, even we get the alpha value is 1000, but it will not select it. It only has got it the minimum beta value as 3. Either it will search for 3 or less than 3. But if we know the alpha value is 7 or greater than 7, then obviously there is no benefit of searching this path. So you simply put it even if you go there also. Let's say minimum value between 8 and 9 and 10, we can see the node K provided us. But here the same thing is here because from this we can get the value of maximum value is minimum value is 9 and maximum value is 10. But here uh, alpha can choose that part, but beta do not choose that particular part because if that part provided by beta, then the probability of maximum value greater than or less than 9 or equals to 9. That means the beta do not provide that particular part. So it already said that the value is 3 or less than 3. Okay, so it was already fixed beta value as 3. So it is saying that either give me 3 or less than 3, but this path taking alpha to 9, even it takes you to the 1000, then also there will be no benefit at all because it is not creating any problem in your final decision, means it is not creating any influence our final decision. So if it is not creating any influence or not affecting at all, then obviously we should not consider this whole part and we put it now. And I know that this path is a good path here because I am getting beta value as 3. Beta value is fixed to 3 and we fix its minimum value to 3. Now we take this value above again as we took it above. So we fix alpha value here to 3, but max value will be 3 or greater than 3. So what you can do max value is the value which you have given to alpha max value will be equal or greater than it. So can this value be greater than 3 or equals to 3? Can we get any other path which can be more beneficial to max because we have already got a path for 3? Can we get more beneficial path? Now we move to the right side. As we move to the right side, beta alpha directly we move to the terminal level and at terminal value is 2. So here beta, so here when we exploring that particular value of C, okay, and that particular, so here we can get the minimum value of 2 or less than 2 for beta and for alpha is 2 or maximum 2. So other hand, we can get the sixth value also 1, 12, 9, 14, 13, 16. But here, we can see uh, eh, value is 2. So here beta value also be will also be 2 at it is a minimum node. Mean node means if beta value is 2, then mean mode value will be 2 or less than 2 because it will not even consider greater than 2. So either its value is be 2 or less than 2. If we see here, if we consider it, if you move here also, then obviously beta value will fix to 1. So as you have fixed beta value to 1, so minimum value to this node will be either to 1 or less than 1. So here beta value is 2, here beta value is 1. So obviously is a max node that we will consider the maximum value between them and max value between them is 2 and this max value is taking you towards value 2. So there it knows that alpha value here is maximum 2. If alpha value is maximum 2, then here beta value here is also 2. Means this mean is saying that I have already gotten path of 2. I want lesser than it. I want either 2 or less than 2. But we have a max. max node already we got an alpha value of 3 already on the max node means this max node is saying that I have already got a path for 3. Tell if there is any path greater than 2 or not, but this beta value is 2, then obviously it will not consider this path, because if it goes towards this side here it will maximum profit of 2, but already it's getting profit of 3, here it will not given go towards the lesser path. So this whole value here will be poon, means we will not even consider it. So if we are not going to even consider them, then obviously our number of nodes which are exploding are reduced now. Even if you consider it according to the minimax event, then it will not choose this path because it's taking minimum value of 2. Here, minimum value of 3 and means max choosing this path, then he knows that he will getting profit at least 3, and if he choose this path, then he will getting the profit of 2 only. When already I have found a path with more profit, then I will not even explore the less profit path. This is actually summary of alpha beta pruning. Thank you.